Good people, welcome to JJ Tech Tutoring. I'll be teaching you quotient rule and product rule. First thing first, you need to know that quotient rule is the one that is having a division, and then product rule is the one that is having multiplication, right? So now, how do we deal with a quotient rule? Quotient rule is this one, and then how to deal with, we have to derive the numerator and multiply it by the original denominator, then subtract the derivative of denominator and the original numerator, then we divide by the square of the denominator. That's how we deal with this, right? And then secondly, when we're dealing with product, we just have to derive the first function and then multiply it by the second function and then add it into the derivative of the second function and then the first division, right? It's as easy as that, and then you're gonna get to understand it when we now start doing examples. Okay, we can just start doing example of the quotient, right? Just y is equals to x4 4x squared plus 4. All right, how do we go about this? That means this 4 here, it's actually the same with f of x. It's actually the same with f of x. So that means we're gonna have to derive this x to the power 4 into 4x to the power 3, because the derivative of x to the power 4 is actually 4x to the power 3. Then we multiply it by the original denominator. We apply it by the original denominator and subtract the derivative of original denominator multiplied by the original numerator. Then we divide it by the square of the denominator, which is x squared plus 4. Then we square it, right? So for now, we can just do the math. 4 times 4, it's actually 16. And then x cubed multiplied by x squared, it's x to the power 5 plus 16x cubed minus 8x to the power 5 divided by, we just have to leave this as it is because already we have solved, we have derived already, so we can just leave it as it is. Then the second one, we can say y is equals to 5x to the power 4 plus 1 divided by 4x to the power 5 plus 3, right? So how do we come up with this? Because it's a quotient rule, we have to derive the first one. So that means it's 20x to the power 3, then the original of the denominator, then we're gonna subtract. When we subtract, we have to now derive the denominator, which is going to be 20x to the power 4. Then we multiply it by the original of the numerator, which is 5x to the power 4 plus 1. Then we divide it by the square of the denominator. So that's how we deal with the quotient rule. So now we have to now move to the product rule. If you have forgotten how I said about the product rule, when you are given something like this in a product rule, that means the derivative of this, that means it's going to be something like this. It's going to be something like this. We have to derive the first one, multiply it by the second one, that is just the original. Then from there, we derive the second one and multiply by the original of the second, right? So how can we come up with the example of this? Number one, we can just say y is equals to x to the power cube 3x to the power 4 minus 2, right? So now, how do we now have to derive this? First thing first, it's dy over dx is equals to, we have to now derive the first one. The first one is actually this. We are not going to distribute this. We are not going to say this multiplied by this, this multiplied by this. That one is old-fashioned. It's mostly high school work, that one. Now here, we just have to derive the first one, which is negative 3x to the power 2, multiplied by the original of this, then plus, we're going to have to derive the second one. We're going to have to derive this one now. This one needs to be derived. Then from there, it's going to be 4 times 3 is 12x to the power 3. after deriving this, we have to now multiply by the original of the first one. So that means it's going to be negative x 3 to the power 6 minus, or now it has to be plus 6x squared plus 12x to the power 6. So it will be negative because of this negative. So that's how it should be. That's how it should be. And then we can just continue and solve number 2. Solve number 2 is just f of x is equals to x squared negative 3x squared minus 2. Right? So here you just have to first derive this one into 2x, copy the original equation, negative 2. Now you have to add this. So now you're gonna have to derive the second one, which is going to be 6x negative 6x squared, then the original of x squared. So it's just gonna be like this. You just have to distribute now, because now it's done. Then from there you gonna enjoy. Now you're gonna enjoy and celebrate. And then now you can also derive the one that is a little bit challenging. It's actually advanced. It's a little bit challenging for all students. So you're given something like this. And then they say find the derivative of this. So that means if you are given something like this and they ask you to find the derivative of this, now you have to do what? First thing first, you have to derive the first one, multiply it by the second one, plus derivative of the second one, multiply it by the first one. Right? So now from there, you're just gonna have to do what? The derivative of e to the power x is just e to the power x, then we multiply it by sine 5x, and plus the derivative of sine 5x is 5 cos 5x multiplied by the original of this. So this is the answer. As easy as that. This is the answer. So guys, it's very simple to derive this. You just have to play with the maths. Now, if ever you're given it like this, in a quotient way, you know very well that you have to derive the numerator, multiply it by the denominator, subtract the numerator, deriving the denominator, and then divide by the denominator squared. Right? So it's going to be 5 cos 5x e to the power x, now minus sine 5x, then e to the power x divided by e to the power 2x. So that's as easy as that. So that, guys, we are done with quotient and product rule. Now you know it so well, you can also solve any complex question that is dealing with quotient and product. Don't forget to subscribe, like, and share. Thank you so much. See you on the next video.